Hello YouTube, Ron this side. So today's video is about HashiCorp Vault, which is an open source tool to store your passwords and other sensitive information inside Kubernetes cluster. So in the world of Kubernetes, managing secrets such as API keys, passwords, and other sensitive information is a critical task. Kubernetes has its own built-in secrets management mechanism, which is known as secrets. But it has certain limitations that might not meet the security requirement of all organizations. For instance, Kubernetes secrets are stored in etcd, which, although encrypted at REST API, might not provide the level of security and access control needed for highly sensitive information. And secrets can be easily encrypted by base64, and it could also be easily decrypted by or decoded by base64 format. So it is not reliable to store your secrets and means your passwords, your API keys, etc. inside secrets. So this is where HashiCorp Vault comes into play. Vault is a tool designed to securely store and manage sensitive information. It provides robust mechanism for dynamic secrets, encryption as a service, and access control, making it an ideal solution for managing secrets in Kubernetes clusters. So in this video, I will be creating a small demonstration like how you can inject your HashiCorp Vault inside your pods or your application, which will uh, retrieve or fetch the data which you have stored in your vault easily. So this is architecture which I will be following throughout my demonstration video. So with this image, you can easily understand that we have a Kubernetes cluster which is running, and we have a namespace defined in which we are running our deployment or application. And we have also associated service account with the specific deployment. And after this, we have a HashiCorp Vault, which we have synced with our Kubernetes cluster. So for syncing our HashiCorp Vault with our Kubernetes cluster, we will be using a service account, namespace, and a role. So these three will be created inside our Kubernetes cluster, and we will be configuring those values inside our HashiCorp Vault pod as well as inside our application pod. So, and another feature of using HashiCorp Vault is if we want to uh, give the rights to access the value of our secrets to specific deployments or pods, we can easily give the same by just mentioning the role as well as the service account inside the manifest of our deployment. So here in the picture, you can see that which like the deployment which is associated with the service account and the role, they can easily access the secret which is created by HashiCorp Vault, and those who are not associated with the service account, they cannot access. So this is a small demonstration or a small architecture to use HashiCorp Vault to store your secrets, and which can be easily used by your Kubernetes cluster. So I will be using this repository to perform my demonstration. You can also follow the same if you want. So these are in the README. I have just mentioned the steps to install HashiCorp Vault, as well as creating the respective role as well as service account. And I have created two YAML manifest file, which is one is for deployment, our sample application, and another is to just create the service account. So let us understand YAML manifest file. So in this service account YAML manifest file, I am just creating a service account which is named as Vault service account, which will be running inside a namespace Vault, and this is the label I have attached. So this is a very simple manifest file, and inside deployment test.yaml. So this is basically a deployment manifest file only, but I have added the service account as well as the role which I will be creating inside my Vault pod as well. So let us understand line by line. So this is the API version. The kind is deployment. This is the name I'm giving it, and it is also being created inside Vault namespace. This is the labels which I have also given inside service account. This is the selector, and only one replica of my application would be running. And here the main thing of this demonstration is starting from here. So this is the annotations. In the annotations, I have given that Vault agent inject should be true, means it is injecting the agent from HashiCorp Vault to this pod, to the application. Means it is a kind of it's a kind of feature like we are synchronizing our Kubernetes pod with the HashiCorp Vault pod, because we will be running the HashiCorp Vault as a pod only. After this, we are giving the agent inject status as update, so that every time we will be updating the value of the secret, it should take the updated value only. After this, we are just mentioning the name from by which we are creating the secret. So in this case, we are creating a name like CLI secret, and it should be stored inside this path secret slash CLI secret. So CLI secret is the name, and secret is the directory where all the secret will be stored. And this is the template of my CLI secret, and this is a like a simple Helm structure, like how you are defining the template. So in this secret, I am just passing one value, which is path token, and it will fetch the data from HashiCorp Vault. So this is how you can hard code. Sorry, you can just use the variable, and no one can inspect like what is the value, because with the inbuilt secret uh, resource of Kubernetes, anyone can easily decode or encode the secret values using base64. After this, in the same demonstration, I am also adding a new secret, which I have named as UI secret. So in the HashiCorp Vault, you can create secret by CLI as well as using the UI. So in my demonstration, I will be using both the methods so that you are comfortable, and you can select whichever form of creating secret is suitable for you. So here also I'm just mentioning the template, and in this secret I'm creating two values. One is username and another is password, and they are getting the data from the variable which I have declared inside my HashiCorp vault. After this, I am attaching the role which I will be creating, and this is the label. And after that, I am just attaching the service account and the containers in Nginx I'm using, so that I can easily use a lightweight container to display the values of our HashiCorp vault. I hope I'm able to explain you what is inside this deployment YAML. It's easy. We are just passing the value of our service account, the role, and the template structure, which we are defining inside HashiCorp Vault. These uh, these annotations are necessary so that we can sync our HashiCorp Vault and Kubernetes pod, or the application pod, so that they can easily fetch or retrieve the values accordingly. So these two YAML manifest file is required for our demonstration. And in the README, sorry, I've just mentioned the steps to install HashiCorp Vault, as well as creating the policies, creating the service account, and making communication between Kubernetes with Vault. So let us jump to the demonstration. So in this demonstration also, I will be taking Killer Coda Playground of version 1.30. So I have clicked on 1.30. Let us wait for the Kubernetes cluster to get up. Okay, so it's ready. First, let us create a namespace with the name of Vault. Then add the HashiCorp Helm repository inside our cluster. Then installing HashiCorp Vault. And now let us just first wait if everything is up uh, inside our namespace or not. Okay, so container is been creating, and this is the agent injector pod, which is basically the backbone to inject the vault details or the secrets inside our Kubernetes cluster. Sorry, not in Kubernetes cluster, inside our application, the deployment or the pod we describe in our cluster. Let us again check if everything is up or not. Okay, so everything is running. So let us go inside our Vault 0 pod to configure uh, the things. So first of all, we have to create a policy so that uh, we can give uh, mods to read or write or to perform actions on the secrets. So for this, I'm just creating a read policy which has the capabilities of read. So you can give many more capabilities as well, like read, delete, write, update, etc. So for this demonstration, I'm just going with read capability. So just copy this and hit enter. After this, we are just uploading this policy. So we have successfully uploaded this policy, and the policy name is read hyphen policy. Now we have to enable Kubernetes authentication in Vault so that Kubernetes can easily talk with Vault. So we have enabled Kubernetes authorization method at Kubernetes. So this is the path. After this, we have to configure Vault to communicate with the Kubernetes API server. Okay, so this is also done. After this, we have to create a role. So the role name I am giving is vault-role, which will binds the above policy, the above read policy we have created to the Kubernetes service account. So service account which we will be creating inside our Kubernetes using kubectl and in the namespace. So in the namespace here, I am creating everything inside Vault namespace. So in short, this allows the service account to access secrets stored in Vault. So let me copy this, paste this. So this is also done. We have created the role and the service account here, which you can see is Vault-service account. So this is the same service account which we have mentioned in our service account.yaml, which we will be creating shortly using kubectl commands. So everything is done in the form of configuration. So let us create a secret using Vault CLI utility. So let us just put the command here. So here the command says that vault, key vault, put secret, and the secret name is CLI secret, and this is the key value pair which we are passing. So let us hit enter. So it has created the secret, and the path here it is secret slash data slash the name of the secret. We can check how many uh, secret is already there or not inside this pod by listing the secrets. So it is only giving one value, which is CLI secret, which we have just created using the CLI command. So till now, everything is fine, and we have easily configured our vault pod. So let us exit from this pod and create a new tab. So in this new tab, I will be just creating a service account and the sample application. Nano my sa.yaml and this one as well, deployment as well. Nano my deploy.yaml. Okay, so if you remember, I have also mentioned that I will be creating a secret using uh, HashiCorp Vault UI also. So let us create that as well. So for that, we just have to fetch the service which is running inside Vault namespace. So we have to access this service which is Vault-UI, and it's a node port service, and the port is 32231. Let us open this port and access the UI application of HashiCorp Vault. Access. So this is the home page, and this is the method by which we can access or sign into the vault. So we are just passing token method, and the value of token by the in the initial step is root, small lowercase root, ROOT. Okay, so this is how the dashboard of Vault looks like, and we just have to navigate to the secrets engine here, and after that we have to click on secret. So this is where every secret will be stored. So here you can see this is the CLI secret, which is already we can see, which we created using the CLI command. So we can also check the value, like what we have passed inside uh, the vault. So this is the value of my token, which is secret created by CLI. If we check the same inside our app cluster terminal, so here also you can see this is the value I have passed. So it is correctly synced, and it is displaying the correct value. Okay, so now let us create another secret, and let us name this as UI secret and pass the value username Rohan, add another one, password, and PASS password. So these are the values I have given for my username and password. Let us save this. Okay, so we have successfully saved our new secret, which we created using HashiCorp Vault user interface. So these two uh, secret we can say that we have created. We can also check the same if uh, the new secret is created or not by just going inside Vault 0 pod and list down all the secret. So here also you can see that it has successfully updated the secret as well. Okay, so now let us directly apply the manifest file which we have uh, just created. Okay, so our deployment as well as service account is created. Let us check if everything is up or not. kubectl get pods hyphen n volt watch flag. Okay, so our deployment pod is running. Let us check if it is displaying if the data is correctly fetched or not inside our pod. So for this, we just have to copy this command and instead of pod name, we just have to pass the real pod name which is running currently, which is this Vault test 777 F6 FB F6F. So yeah, here you can see that defaulted container nginx because we passed this container image and we can easily list down the secrets which we have created using HashiCorp Vault. So one is created by CLI method and another one was created by user interface. Okay, so let us now check the values of each secret we have created. So for that, we just have to use cat command. So let us first check the value of CLI secret. So for the CLI secret, it should just pass the path token value, which was secret created by CLI. So yeah, you can easily see that this is the value which we key value pair which we created using CLI. Now our turn for UI. So now here it should display the value of username and password. So here it is. It is correctly showing username is equal to Rohan and password is equal to Rohan. So yeah, this is how you can inject your secrets inside your application using HashiCorp Vault. So let us just do like a small experiment, like by updating the values of our secret using UI. So let me just upgrade the token value. So for updating the value, we just have to click on create new version of this secret. And so instead of secret created by CLI, let us just pass numeric value as well, 123, and save this file. And again, if we check the value of our CLI secret, then what do you think? Should it display version 1 value or version 2, which we just updated using UI? So it is just showing the version 1 value, and this you can say that it has not updated the value. So for updating the value, you just have to restart this pod. So for that, you just have to delete this pod first. Qctl delete pod vault test hyphen n vault. So it is deleted. So it is deleted. Now let us check the new pod name. Let us wait for it to get running. Okay, so the pod initializing has started, and this is the new hash ID given by Kubernetes to this pod. Okay, so now let us use exec command kubectl exec cli execute, and we just have to remove this ID and use a new ID which is GM57Z. So now it should display the the new value which we updated using UI. Boom. So here you can see that now it is showing secret created by CLI 123, which we added using our UI dashboard. So here is how you can easily use HashiCorp Vault for your complex application as well, so that you can inject secrets, API value, key pairs, etc. inside your application without the worry of getting decrypted by hackers or by somebody else. HashiCorp Vault is a open source tool which is maintained by HashiCorp, and HashiCorp also has various tools like Terraform, etc. So you can rely on HashiCorp uh, platform for creating or saving your secrets safely. So yeah, this is it for the demonstration and for this video. I hope you all guys liked it, and I was able to explain you how you can use HashiCorp Vault inside your Kubernetes cluster. Thank you. Have a nice day.